Hello, in this video I'll be talking about experimental probability. Experimental probability is different than theoretical probability, which is what we talked about in the last video. Experimental probability is based on experimental data or observations. Oftentimes you'll use experimental probability when the different outcomes are not equally likely. For instance, when I talk about tossing a cup, it's not equally likely that a cup will land on its top or its bottom or its side. They have different likelihoods. And so experimental probability would help in that case to determine what the actual probabilities are. So for experimental probability, the probability of an event is the number of times an event occurs over the total number of trials. For instance, if we talk about free throws, if in a game someone takes 20 free throws, so that would be the total number of trials, and makes 12 of them, okay, so the probability of making a free throw, making FT, is 12 over 20, so total number of times the event occurs, so making a free throw happened 12 times, total number of free throws was 20, then that would mean this person has a 6 over 10 chance, or 3/5, or 60% probability of making a free throw. Now in manufacturing, you often talk about companies like to test their products, and those products could be anything from a new car or a bicycle or whatever, but let's talk about batteries, for instance. So let's say Duracell makes 10,000 batteries in one day, for instance. So 10,000 batteries a day. I made that up. I'm not sure how many they make. It's probably more than that. But let's say out of those batteries, they test 100 of them. So test 100 batteries. This is kind of similar to some of the stuff we were talking about in the last chapter. But out of those 100 batteries, 3 of them don't work. 3 batteries don't work. Okay. So in this case, theoretically, you can't use theoretical probability because there's not an equally likely chance that a battery works and doesn't work. So you have to use experimental probability here. So if we want to say the probability that the battery doesn't work, we could say, well, the number of trials in this case, because we're testing 100 batteries, would be 100, so that's on the bottom. And the number of favorable outcomes in this case, the battery doesn't work, would be 3. And so that's going to be 3% of the time it doesn't work. Now you can use that information to set up a proportion, like we did last chapter. Let's say don't work over total. So you could say if 3 don't work over 100, then we think that how many wouldn't work over 10,000, which is how many they make in a day, which is what I made up. And so we can figure that out by solving this proportion either with cross products, or in this case 100 times 100 would be 10,000. So the company would assume that 300 of the batteries they're making each day would be defective or wouldn't work. Okay. So you can also use experimental probability to simulate an event. In this case, the probability that 2 of 3 children in a family are girls. So if we assume that girls and boys are equally likely, we can simulate the problem by tossing 3 coins. Okay. Keep in mind the probability of getting a boy is actually slightly larger. It's like 51% to 49%, but really close to 50-50. And so let's say you're tossing coins, and so you get heads, 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 tails. You got heads, heads, tails again, heads, tails, tails. So that looks like a pie. Split that up. So this one will be heads, tails, tails. And then we got a tails, tails, tails. Another heads, heads, tails, Heads, tails, tails. Heads, tails, heads. Anyway, let's do 2 more just to make it out of 10. So let's say that girls were the H's and boys were the T's. So if we assume that girls and boys are equally likely, we can simulate this problem. So the probability that 2 of 3 children were girls or were H's, and we can figure this out. So that happened here, it happened here, it happened here, it happened here, and it happened here. So 1, 2, 3, 4, 5 times out of 10. So we would say the probability that 2 of 3 are actually, I'll use the one up here, equals, it happened 5 times out of 10. So 1/2 or 50%. So that's how we can use experimental probability to make an estimation of what the actual probability is. Thanks for watching.